Hi everyone, I am Raja Tufail Hussain and today I am going to present assessment of fresh and mechanical behavior of fiber reinforced geopolymer composites with dolomite. So I am going to present on the behalf of my co-authors Ali Raza, Abdul Latif Selmi on 5th International Eurasian Conference on Science, Engineering and Technology on 26 to 28 June 2024. Basically, this presentation explores a new type of concrete called geopolymer concrete, which offers an eco-friendly alternative to traditional cement. Traditional cement production generates a significant amount of carbon dioxide, contributing to environmental pollution and climate change. Geopolymer concrete, on the other hand, uses industrial byproducts like fly ash, concrete, and uh, ground granulated blast furnace slag (GGBS) and dolomite, significantly reducing carbon dioxide emission. In this study, we also incorporate polyethylene (PE) fibers to enhance the concrete strength and durability. Our primary goal is to evaluate how these alternative materials affect the concrete's fresh and mechanical properties such as workability, compressive strength, tensile strength, electrical resistivity, and ultrasonic pulse velocity. We conducted various tests to compare different mix designs, focusing on the optimal combination of fly ash, GGBS, dolomite, and PE fibers. This research aims to provide insight into potential of geopolymer concrete as a sustainable building material that not only mitigates environmental impact but also offers superior performance characteristics compared to traditional cement. By exploring these alternatives, we hope to contribute to development of more sustainable construction practices. Making traditional cement releases a lot of carbon dioxide, contributing significantly to pollution and climate change. It involves burning limestone and fossil fuel, which is harmful to environment. On the other hand, geopolymers use waste material like fly ash, slag, which means they produce much less carbon dioxide and use less energy. They also create less pollution overall, plus geopolymers are stronger and last longer, making them much better choice for environmental and construction needs. So the focus of our study was utilizing fly ash and ground granulated blast furnace slag as a primary binder, also introducing dolomite as a partial replacement for traditional binder, and enhancing mechanical properties with polyethylene fiber. So we use different materials. As a binder, we used fly ash, GGBS, and dolomite. And we use polyethylene fiber, and other components were fine aggregate, coarse aggregate, super plasticizers, and alkaline activators. So we use different mix proportions. Uh, all the binder content was 498 kilogram per meter cube, and PE fibers were added to specific mixes to study their impact on mechanical properties. So, slump tests conducted to determine workability of fresh concrete, and we also measure compressive strength by using 100 cubes, which were tested at 7 days, 28 days, and 90 days. We also find split tensile strength by measuring by testing cylindrical specimen at 7 days, 28 days, and 90 days, and we also found out electrical resistivity and ultrasonic pulse velocity. So the results of SLAM test revealed that fluid and workability of concrete mix is uh, measured when we added dolomite and GGBS to geopolymer concrete. The mix became less workable and didn't flow easily. This is because dolomite absorbs more water and has finer particles. Adding polyethylene fiber also made the mix stiffer, further reducing its fluidity. Overall, mixes with more dolomite and fiber had lower slump values, meaning they were less easy to work with. The compressive strength test showed that adding dolomite and GGBS to geopolymer concrete made it much stronger. Mixes with these materials had higher strength at 7 days, 28 days, and 90 days compared to mix without them. The mix labeled Fa80 G20D0 was strongest. Thanks to beneficial reaction between material, over time the concrete continued to get stronger due to ongoing chemical reactions. Overall, using dolomite and GGBS significantly improved the concrete strength. Tensile strength test revealed that adding dolomite and GGBS to the geopolymer concrete also improved its ability to resist cracking under tension. Mixes with these materials showed the higher tensile strength at 7 days, 28 days, and 90 days compared to mix without them. The electrical resistivity test showed that adding dolomite and GGBS to the geopolymer concrete improved its resistance to flow electrical current, indicating better durability and lower permeability. Mixes with these materials had higher resistivity at 7 days, 28 days, and 90 days compared to the mix without them. The Fa80G20D0 mix had highest resistivity, suggesting it has fewer pores as is less likely to allow water and harmful chemicals to penetrate. Ultrasonic pulse velocity tests showed that adding dolomite and GGBS to geopolymer concrete improved its internal structure. Higher UPV values indicate better quality and integrity to concrete. Mixes with these materials showed faster pulse velocities at 7 days, 28 days, and 90 days compared to the mix without them. The Fa80G20D0 mix had highest UPV values, meaning it was densest and has the least internal defects. So conclusion involves adding dolomite and GGBSE to geopolymer concrete significantly enhance its compressive and tensile strength as well as its electrical resistivity and internal quality. And also, while these additions reduce the workability of fresh mix, the benefits in strength and durability outweighs these drawbacks. And geopolymer concrete using industrial byproducts offer a sustainable alternative to traditional cement, reducing carbon dioxide emission and utilizing waste material effectively. And for future direction, further studies should focus on long-term durability and performance of geopolymer concrete under various environmental conditions.